Thank you everyone for coming. It's great to be here. I actually feel more pressure than normal to do a good job because the conference organizers have been so wonderful. This talk barely fits into 45 minutes and we're starting 3 minutes late, so we're already behind. It's like the Oscars. We're already in trouble. I'm Steve Smith, and I'd like to talk about the theory of constraints and specifically how it can make it easier for you to implement continuous delivery. So as I said, this talk is really barely fitting into 45 minutes. So if you're using the app, which I'm not, you can do the speaker feedback now. So if you could just put in, he talked too fast, his sense of humor is far too dry, and I really admire the way he didn't mention the word DevOps at any point because he so strongly believes that it's a cargo cult of increasingly less value. So if you do that now, then that would be really helpful. We'll save time at the end. And that's the only time I'm going to say the D word because the D word makes me sad. So I'm happy to take public questions at the end. If we run out of time or if you prefer to speak one-on-one, then just come and grab me afterwards. I'm here tomorrow as well. I'm a continuous delivery consultant. I'm the author of Measuring Continuous Delivery, which is a book on LeanPub about how to make better decisions when adopting continuous delivery. I co-authored a Children's A to Z of Continuous Delivery and Build Quality In, and I'm a long-term associate of Equal Experts, which is a network of software delivery experts, increasingly with an increasing number of European offices, actually. Implementing continuous delivery is all about improving the stability and throughput of production deployments until you can meet product demand. It's very, very easy to not meet that success criteria, as I can tell you from experience. What makes continuous delivery so challenging is trying to apply the wealth of technology and organizational changes that are recommended to the complex adaptive system that's your organization. In your unique circumstances that no one else can really relate to unless they work with you, you will be constantly surrounded by half-baked theories, off-the-shelf solutions from Oracle that just don't work, and everyone telling you that Amazon's fine, Amazon won't be bothering with us. We can go up market, they'll leave us alone. If only that was true. They're just bored eating another company at the moment. That's why they're not eating you yet. How do you actually apply all of these changes then to your organization? And how do you avoid spending weeks, months, maybe years on changes that ultimately don't improve on your time to market? The advice on how to do that has evolved over the years as we learn more about the field of continuous delivery. Back in 2010, Dave and Jez wrote Continuous Delivery, and in it they recommended that we use the Plan, Do, Check, Act cycle by Dr. W. Edwards Deming, and we should use that to implement a maturity model of configuration and release management practices. So 9 years on, 50% of that advice is gold dust and 50% of it is not. Sorry, Dave and Jez. So the Plan, Do, Check, Act cycle is wonderful, and we should all be using it. It's a great way to structure experiments that are aligned with the scientific method. Maturity models are not a great idea. They are hocus pocus. The idea that a linear, one-off, step-by-step transformation will somehow help is just at odds with the idea of continuous improvement, and it's ignorant of the inherent complexities in organizational change. So we need to do better than this advice. I can tell you from experience that we need to do better than this advice. Whatever you do, don't do what I did a good few years ago now, actually, where I used the Plan, Do, Check, Act cycle to try and automate the world, let's say. So I worked as a tech lead at a telco in Britain, and we had 6 extreme programming teams, and we were responsible for 28 applications that came together into a platform called Network Activation. That's obviously not its real name, but that's, disguised just badly enough that I have trouble remembering the real company and therefore can't say its name out loud unless I'm, I don't know, drinking or something. What can I say? We had lots of problems in our technology value stream, in the build, testing, and operational activities between code commit and customer. So after building a release candidate, we had a functional test phase by a different testing team, and then we had an integration test phase, which was like a 10-day test for some regulatory reason that I never really understood. And then the various operations teams did some kind of magic, and a production release would happen. So I kept hearing how many problems we had, and I had worked with Dave Farley for a couple of years, and I'd read the continuous delivery book a couple of times. So I was like, I know what to do here. So I calculated our average lead time and found out that it was 34 days, which seemed too long. And I volunteered to build a deployment pipeline. Straight away noticed that I volunteered to build a deployment pipeline, not volunteered to improve our time to market. That's the first signal that I'm going to get this wrong. Our focus was on reducing toil and reducing rework and having a release process that's repeatable and reliable. Again, more signals that we're pointed in the wrong direction. There was no product owner because the company was full of projects and project managements and a project management office that wouldn't talk to me, not after the incident. So I invented a target lead time, essentially, of 14 days, which now seems ludicrously optimistic. So here's an incomplete checklist of the technology changes that we considered. Blue are things that we already had, white were things we probably should have been doing maybe. So we had some great version control practices, we had test-driven development, we had acceptance test-driven development. All the code repositories were hosted in Subversion, so trunk-based development was much easier, which was great. And we were doing continuous integration. And yes, that means that all 6 teams had team members that were committing to trunk at least once a day. That's what continuous integration is. Stop creating tools and selling them with CI in its name. That's not a thing. On the other hand, Solaris environments were manually provisioned. Releases ran off a Perl script that didn't work, and nobody knew Perl anyway. Does anyone? Oracle database migrations were semi-automated. No one ever says they know Perl, do they? It's just kind of inflicted on them. So Oracle database migrations were like kind of semi-automated at best. And production releases took 8 hours. There was like a 10-step release implementation plan, so they had to happen overnight. So over 18 months, we made a lot of progress. We ran a bunch of experiments, loosely structured around plan, do, check, act, and we gradually figured out what worked and what didn't work. We created a fully automated deployment pipeline. We created an almost fully automated database migrator, and we used branch by abstraction and consumer-driven contracts to incrementally decouple these 28 applications so that they could, in theory, be released together, or we could just cut down on build times. And here's a checklist of organizational changes that we thought about and tried to do some of. So what did we have? We had teams making their own decisions, which was great. We had pair programming all the time, so we had continuous change reviews. But development teams were sliced horizontally by technology layer rather than vertically by product domains. There were lots of tensions between teams, lots of difficult communication pathways. And development teams very clearly had responsibility for features, while the operations teams have responsibility for stability, because the organization clung to the fantasy that throughput and stability are somehow mutually exclusive. So we made some limited headway here over 18 months. We decoupled our applications, which meant that we had a smaller batch size. We improved traceability in our release candidates, but we didn't really get a lot done here. I think one thing to remember is that we had an iteration manager who really pushed for the testing phases to happen as quickly as possible. All right. So after 18 months, we had reduced platform build time from 1.5 hours to 3 minutes, release time from 2.5 hours to, I think, 1 hour, something like that. And if we'd got all the way with database migrations, that would have gone down to like 5 minutes. But our pipeline metadata showed us that after 18 months, our lead time had been reduced from 34 days to 31 days. So 18 months of hard work for a 3-day improvement. It's nice that people laugh here. Of course, people laugh at that like, oh, wow, 3 days. Like, you try it. Hindsight bias is lovely, isn't it? I love this. At the moment I started writing this talk, I was like, everyone's going to have some really awesome hindsight bias in this. This is going to be amazing. I wish someone had done a talk by now, like it was videoed, like really well videoed, with proper audio, and then it would be hindsight bias. And then whenever people giggle at this point, I could just flip and show them that video, and we could just sit in silence and watch it. That would be amazing. Right, that's cost me another 2 minutes. That's good. So, where am I? So, this obviously isn't great, right? We wanted to get to 14 days, we got to 31 days. By the yardstick that I tell every client to use, this continuous delivery program was a failure, just because I was the architect, product owner, developer, tester, and cheerleader in chief. doesn't mean it was a success, okay? And we never knew what the major impediment was in the technology value stream. We didn't know what made it so hard for us to go from below 31 days. We had no clue. Hypotheses of the time included it was the DBA's fault, which didn't seem right. It's always interesting how people say it was the DBA's fault, and then when you say, do you mean Sarah or Kenny? And they're like, they don't actually want to commit to a name, do they? Anonymous feedback is not a good idea. So what else? People said that the 10-day integration test took longer than 10 days, but we didn't have any data on that, so we didn't know. And people said that the interactions between different operations teams were injecting delays that we couldn't see. Well, that was possible because 2 operations teams didn't actually talk to each other except through the medium of email, so that was possible, but I didn't know what it was, if I'm honest. All right, so what have we learned since the good old days about implementing continuous delivery? Well, in 2015, Jez Humble, Joanne Molesky, and Barry O'Reilly published Lean Enterprise, which is somehow underrated. It's like a great book. And in the book, Jez, Joanne, and Barry talk about using the improvement kata as a continuous improvement framework, which is a fantastic idea. And they talk about iteratively and incrementally proceeding with like rapid cycles of experimentation. When they do that, they're talking about the plan, do, check, act cycle. It plugs really nicely into the kata. So this dovetails beautifully with continuous delivery, and it's something I try to do on all of the continuous delivery programs that I work upon. I just don't tend to call it the kata. I tend to just talk about milestones and incrementally improving. All right, so in 2018, Dr. Nicole Forsgren and Jez and Jean Kim published Accelerate, which provides us with a statistically significant underpinning for all of the continuous delivery practices that we know and love. Who would have thought that trunk-based development would be strongly correlated with high IT performance and organizational performance? Like, yeah, not me. I've never seen that succeed really, really well. That wasn't true, by the way. If you're not used to my sense of humor, I don't mean that. I mean the exact opposite. Like, it works really, really well, and you should do it. This book is great because it name checks approvingly the improvement kata, plan, do, check, act, and it rubbishes maturity models, which is fantastic. And there's some really good stuff in there as well about capability modeling. All right, so in 2018, I finished my own book, Measuring Continuous Delivery. I told my wife it would take 6 months of 3 evenings a week. It took 2 years. If you're thinking of writing a book and you have a young family like me, I have some advice for you. Like, stop it. Just write a blog post and then leave it alone. That advice is free. You're welcome. So over the years, I've given a lot of thought, actually, to what happened with network activation. And through various experiences with different clients and chats in the community, I've come to the conclusion that so the continuous delivery gave us the plan, do, check, act cycle, like good. Lean Enterprise gave us the improvement kata, that's good. And the Accelerate gave us capability modeling, that's good as well. But it's still not enough. We need a way to quickly identify the major impediments in a technology value stream. We need a way to select the experiments that are most likely to succeed. And we need a way to visualize throughput so we can understand and try to generate insights. If we don't have that, then there's a strong probability, in my opinion, of stakeholder dissatisfaction, suboptimal outcomes, and discontinuous delivery remaining the norm. I actually invented the term discontinuous delivery. I went to thesaurus.com a while ago and just looked for antonyms of continuous. I didn't even know that discontinuous was a word. But now I frantically use it in as many scenarios as possible in a hope that it will gain some kind of marketing traction, but it's not been successful so far. So what can we do when we don't have all the necessary heuristics available to like solve these problems in one go? In other words, what can we do when our surname isn't Farley and our forename isn't Dave? What can we use that complements the plan, do, check, act cycle, the improvement kata, and capability modeling? So one thing we can do is we can use a deployment throughput indicator. So this was a technique that I cooked up a couple of years ago now, and it's about visualizing the throughput measures that Dr. Forsgren, Jez, and Jean recommend in Accelerate. So here I've actually applied the technique back onto the historical data from network activation. So if you haven't done a bit of hindsight bias, then now's the time. You know, you're going to enjoy this. So our x-axis, is this red finger to work? Yeah, look at that. It's amazing. Tools. Tools are underrated. I don't mean that either. So the x-axis is the 18 months of work that we did. That's our timeline. The y-axis is, it didn't work, you see, tools are useless. The y-axis is calendar days, 0 to 45. The orange line is average lead time. That's the time between code commit and customers. And the green line is average interval. That's the time between production releases. Do you have anyone here who's colorblind? If so, I can wave and like point out which one. No? Okay. So I wish we'd had this back in the day, because when I look at it, I can see straight away that our lead time is greater than our interval. So that means that we were releasing to production more often than we could build and test the thing. So for a year, we were releasing to production every 21 to 28 days, but it took us 34 days to build and test the thing. No wonder people were so stressed and burning out. Like, we had more problems than we realized back then. We then had an improvement. We got down to 28 days, but unfortunately that's a mirage. That was because we crunched some releases in right before an end of calendar year change freeze, or as this company liked to call it, a period of heightened awareness, which is basically a polite term for a change freeze, where you actually accept that some change will actually have to happen without people blackmailing each other. All right, so, and then at the end of the 18 months, we actually had our real 31 days. That's our 3-day improvement. So this has given us some useful information, but it still doesn't tell us what the major impediment was. To find the impediments in a technology value stream that matter and uncover the experiments most likely to succeed, we can use the theory of constraints by Dr. Eli Goldratt. Who's familiar, please, with the theory of constraints? Gwen shot her hand up then, so excited. She was like, yes, teacher, I know it really well. Like, well done, Gwen. Proud of you. I would have been the same. Would have been like, yeah, of course I know it. Get on with it. So the theory of constraints is basically fantastic. It's a management paradigm for improving organizational throughput by optimizing a smaller number of constraints in a homogeneous workflow. This is applicable to continuous delivery and a technology value stream, because between code commit and customer, there should be a homogeneous workflow. Your build, testing, and operations activities should be deterministic. They should be invariable, okay? If that's not applicable to product design, then you need to be thinking about Don Reinertson's work rather than Dr. Goldratt's. So the theory of constraint is laid out in The Goal, which is a business management novel thing. If you haven't read it, you should. If you've read it, then please read it again. There's a graphic novel out that's really good as well, but it's just this fantastic book. And the central premise of the theory of constraints is to, well, he said it best. So instead of balancing capacity demand, you should try to balance the flow of product with demand from the market. That's kind of similar to what we say about continuous delivery, interestingly. Okay, so the theory of constraints teaches us that a non-constraint is any resource with capacity greater than market demand. Its level of utilization will be controlled by a non-constraint, will be controlled by a constraint elsewhere. And increasing its capacity is a waste of time and money, because it won't help you tackle the queue of work prior to a constraint, nor the starvation of work after a constraint. Okay? So in a continuous delivery context, we can say that there are a number of unconstrained activities in a technology value stream, and they take less time to complete than our target lead time. And they can only happen as often as a constrained activity will allow, and we should ignore them. We also learn from the theory of constraints that a constraint is any resource with capacity equal to or less than market demand. Its level of utilization will limit throughput elsewhere, and losing an hour here loses an hour for the entire organization. So losing money here gets expensive pretty quick. Again, in terms of continuous delivery, that tells us that if an organization is in a state of discontinuous delivery, there will be at least one and at most a few constrained activities between code commit and customer. And that will control how often unconstrained activities occur. And losing time in a constrained activity is a really big deal, and you should avoid it at all costs. All right. So there are plenty of reasons why an activity might be constrained, and helpfully the theory of constraints breaks constraint time down into queue time, preparation time, process time, and assembly time. Queue time is the time we spend waiting for an activity to begin. This might be due to us waiting for a new environment to be provisioned, environment contention between teams, or handovers between different teams, say between a testing team and an operations team, if you like. Preparation time is the time we spend waiting for an activity to be set up. So that could be caused by us waiting for a database migration before we can start testing. What else can we say? Waiting for a release manager to complete a release implementation plan if we're in a really big, scary enterprise company. Or maybe we have a third-party seeding test data, something like that. Process time is the time we spent actually doing the thing. A constraint here would be due to a long-running task, like some awful suite of end-to-end tests. As often as I beg people to stop doing end-to-end testing, they insist on continuing to do it. Or perhaps you have a set of tasks that are actually performed by different teams. Maybe you have one team of testers that run the test, and you have a second team of testers that actually analyze the test results. I feel like that should have had more like horror and more people like fainting in the aisles. Like companies do still do that, but everyone here is like, yeah, of course companies do that. Like, of course you have one team of testers check up another team of testers. That's a great idea, Steve. Why don't more companies do that? Right, and assembly time is the time spent after an activity where we wait for an activity to finish. A constraint here might be due to a slow-running parallel activity. Perhaps two releases have to go out together for reasons, and the testing of one release candidate is so much slower than the other that everything just grinds to a halt. In my experience, you'll normally find a constraint in queue time or process time, but that is not always the case. Okay, so if we apply a theory of constraints lens back onto network activation, what the hell happened with that 31 days? So here's like a per activity lead time breakdown. This is a visualization that I use with clients increasingly often. So again, on the x-axis, we have the 18 months of hard work. The y-axis is our calendar days. And each bar is a 6-month period, and it's the average lead time. So the blue area is the time spent in the first functional testing activity. The red bar is the time spent in the red integration test activity. And the dark yellow bar is the time spent in the production activity. And our dotted green line is the target lead time of 14 days, which we're nowhere near. So we didn't have this all those years ago, but I wish we did, because at a glance, you know what the constraint is. Could someone shout out which one's the constraint, please? Production. Thank you very much, mysterious stranger. Yes, it's the production activity, which was news to me when I figured this out about a year ago now, when I applied this technique back onto the historical data, because we never looked at production. We had nothing to do with it. We were looking in all the wrong places. That's a really nice feeling. So we can figure out what it was by taking that heuristic of it's usually queue or process time, and then applying that to this. So if we split each activity into queue time and process time, like temporarily forget preparation and assembly, and if we use lighter colors for queue time, then we can clearly see that the constraint is queue time before production. Over 18 months, it's 15 to 18 days. It never dawned on us that the problem was waiting for a production release. We never tried to tackle it, never thought about it. Actually, we can see where the 3-day improvement came from 34 to 31 days. Over the 18 months, we eliminated the queue time in front of the two testing activities, in front of the two test environments. You might remember me at the start talking about an iteration manager who stood behind the tester saying, please start now, please start now, please start now. He saved us 3 days, although I think he burned out in the end, poor guy. Like, that was the one thing that we changed that improved lead time. All of the automation that we did helped with variability and rework. Like, we got to a point where our interval and lead time started to align, so we were releasing at least on a sustainable pace. But we didn't make a dent in that production queue time because we didn't know about it. Now, when you look back on it, it does kind of make sense, and it was caused by a process that we entirely owned ourselves. Our release manager would have to set production release dates with an upstream billing system, and he would set those dates in advance, up to 2 or 3 months in advance, because the paperwork process was pretty painful. So that's a great example of like a local optimization where for the individual that makes perfect sense, and I would do the same if I was that person. But with a holistic perspective, that's an awful thing to do, because then you're locking the company into discontinuous delivery before anyone's even picked up a keyboard. Okay, because you already set the production release date. What happens is, if the testing is delayed, you push out the release date. But if the testing is faster than you'd expect, you don't bring the release date in, you leave it where it is. So it was great fun working in that company, made some great friends. I learned an awful lot. But yeah, I kind of think about that queue sometimes. And now when I work with clients, one of the first things I do is make friends with the release manager and ask who they have to talk to about release dates. Okay, so now we know that the theory of constraints is a good idea with continuous delivery. How does it actually work? So we use the 5 focusing steps as you'd expect, which are set out in the goal. We identify the constraint, we exploit the constraint, we subordinate everything else to the constraint, we elevate the constraint, and then we repeat the process. This is not only how we look for the constrained activity, this is also how we select the experiments that are most likely to succeed. All right, so identifying the constraint means calculating your target lead time, calculating the duration of each activity in the technology value stream, and make sure you include the queue time, of course. And then whichever activity takes up the most time in your lead time, the one that won't let you reach your target lead time, that's the constraint, no matter how unlikely it might seem. So let's say, for example, we're working together on this, like how many continuous delivery consultants, can one company have? All of us, hopefully. And let's say that we found out that there's a shared performance test environment that's our constraint. All right, so then we need to exploit that constrained activity. That means making sure that it's always working. That means eliminating idle time. That means eliminating defective release candidates before they even reach it. There's plenty of changes you could try here. You can let your imagination go wild. We could automate deployments, automate the performance tests, reduce the duration of the performance tests. We could increase the number of testing slots so that there are some that run overnight. You can make sure that testers don't go to lunch at the same time, so there's always someone available in case the environment stops working, because you want it running 24/7 if it's your constraint. You don't want it to have any idle time. All right. Subordinating everything else to the constraint means slowing down release candidates reaching the constrained activity to match as fast as it can go. And this is a bit of a mindset shift for folks, because that sometimes means that folks are stood around doing nothing, which is fine. The important thing is that the constraint is going as fast as it can, not that the people in front of it are going as fast as they can. So one thing you can do with that is work in process limits. We might set up some work in process limits on a team board so that you can never have too many code changes happening at once. You can never have too many release candidates arriving at the performance test environment. If the developers hit a WIP limit and they can't do any more coding, what should they do?
Help test.
Thank you, mysterious stranger. They should help the testing, and that's the right thing to do, because you're not paid to code, you're paid to solve problems. The testing in that constrained environment is more important than bashing out new code. I'm not sorry if that makes you sad. Elevating the constrained activity means spending money to buy more time. So exploiting the constraint is saving time, elevating is where you buy more. And there's a bunch of different ways you can do that. We might hire more testers. We might do some training courses for testers to sharpen up their performance testing skills. We might improve the hardware in the performance test environment, or we might just look at skills liquidity across the whole team. And then finally, we look at the constraint again. We check out the experiments that we've run, try to understand their positive or negative impact, and then start all over again. We keep doing this until the flow of release candidates through to production meets product demand. And then you're in a state of continuous delivery. Well done, you. Of course, that then means that a constraint will emerge upstream in product design or downstream in custom marketing, but that's a problem for another day, right? Like, well done. Okay. I can tell you that using the theory of constraints in this way, with Plan, Do, Check, Act, with the improvement Carter, can succeed, and succeed quicker than you might expect. So over a year ago now, I worked as a continuous delivery consultant at a media organization on their multi-team on-premise MediaTek media platform. If I'm polite, I'd say it's a complicated technology landscape. There were 6 development teams working concurrently in the same monorepo, on the same monolith, built on top of an enormous vendor product it's best not to think too hard about. We had challenges in development, in testing, and in operations. Beyond the development teams, there was an integration test activity by a different testing team, and then there was a release testing activity by another testing team, and then the operations teams, of which there were several, did their magic, and then a production release happened. So we knew that production releases happened every 3 weeks. That's because we had a product owner, a really knowledgeable test and release manager who was just a great person to work with. And they set a very clear vision of success. They wanted us to achieve weekly releases in as short a time frame as possible. And they also made it clear that the MediaTek platform would eventually be replaced by a new and exciting microservices architecture in the cloud where all the cool kids were working. So that's kind of music to my ears because we've got a clear challenge and there's also a mandate to not boil the ocean. And that was actually increased when I learned that a team had come in before myself and my colleagues, and they had built out a fully automated deployment pipeline, that there were many manual and semi-automated steps in this process. And another team came in and were like, we'll automate everything. And then after 4 months, it was rejected by the operations team very politely because they had never been involved in the process. They just didn't want it. Okay, so there were a lot of technology challenges. Linux environments were manually provisioned. Release candidates were mutable, which kind of horrified me. Releases ran off a Jenkins script to a WebSphere cluster, which didn't behave because WebSphere. On-premise servers ran out of disk, ran out of memory, or just ran away. And production releases took 8 hours. There was a 60-step release implementation plan that I thought was just really awesome. And releases had to happen overnight. But we did have trunk-based development because it was Subversion, which was like, yay, branching's hard, so we're doing the right thing. And there was test-driven development, and version control was pretty good. And there were plenty of organizational challenges. You know, there were multiple teams surrounding each activity. Different testing teams had different suites of end-to-end tests. The best thing, which happened before my time, which was the product owner's idea, was that even though we released to production every 3 weeks, every week a new release candidate was built and had some automated tests done. So every week there was a new release candidate built, put on the shelf, and then every 3rd week it was pulled into production. So that meant that the earlier teams in the process were already working to a weekly rhythm. So that was a great way to drag down batch size, even if you can't do it all the way through. All right, so happily, this was only a year ago, so I knew about things like the theory of constraints and its applicability to continuous delivery. And after 2 months, we built out our lead time breakdown. So the x-axis is our 6-month program, and the blue area is the first integration test activity. The red bar is the time spent in the release test activity, and the dark yellow bar is production. And we can see in May at least that clearly the release test activity is the constraint on our target lead time of 7 days. When we break that down into queue time and process time, the queue time in the lighter colors looks pretty bad, but there's some context. The release process ran from Wednesday to Wednesday, so in the 14 days it took to actually go from release candidate to production, which then happened every 3rd week. 4 days of queue time were actually weekend days where people weren't working. So the queue time wasn't as terrible as it looked. The release test activity itself in process time was the constraint. And this wasn't a shock to many people. There had been hypotheses flying around for a while about how it was a bit of the Wild West in there. So myself and some colleagues really delved into it, and we found that there was some really brittle end-to-end testing. Hardware was pretty old. It was very inconsistent in setup compared to other environments. There were issues that repeated themselves between releases, which is never good. And we estimated it would take us 3 to 6 months to really get to grips with the problems there and start to improve on this activity and drag us down from 14 days down to 7 days on our lead time. But then I had an idea. So there's a great bit in the goal where the plant is going really well. I mean, the book is all about applying lean operations to a failing manufacturing plant. And when the plant starts to improve, they go to the sales guys, and the sales guy's like, I've got this ginormous order that I want to do. And the manufacturing folks go away, think about it, and say, okay, we can't do this ginormous order, but we can do it in smaller batches, in chunks, and that will actually happen faster. Like, they go and actually negotiate on the target lead time. So we were releasing to production every 21 days. The client wanted to do it every 7 days. So I kind of skipped along and said, why don't we just start with trying for fortnightly? Because the data showed us that the release test activity was a constraint on weekly deployments, but not on theoretically on fortnightly deployments. And the product owner kind of went along with it. You know, I talked about it as a stepping stone towards working towards weekly and uncovering more problems. And if you haven't noticed, that's me using the improvement Carter, but not by name. Like that's the very essence of it. Your current condition is we're doing something every 3 weeks. The vision of success is doing it every week. And your intermediate milestone, your current target condition, is fortnightly. So we met with the operations team. You want to do that as early as you can, like on day one preferably. We shared our lead time breakdown, and we invited them into a conversation. We expressed our belief that the release test activity was a constraint on weekly deployments, and they agreed. They were just like, yeah, of course it is. And I was like, awesome. But then interestingly, they revealed an unseen constraint on fortnightly and on weekly. It was the release manager who had a ludicrous workload. I don't know how they did it, but they were responsible every 3 weeks for coordinating releases in test environments, running a CAB meeting, writing the 60-step release implementation plan, chasing people up for release notes. There were 3 teams that produced 4 different release notes, so they needed a lot of chasing. This person also had to chase development teams by email to like update a call-out rota. And I'm sure, and their day job was they actually managed prices in live to check against customer expectations. So we didn't see that in our data. We didn't see that production preparation time was a constraint because there was no data. The release manager never told anyone that they had all this work to do. They just kind of did it, which is admirable, but they were, a really nice person that was burning out, I fear. So the operations team agreed in principle to fortnightly releases on the grounds that we could reduce the workload for this individual. All right, so which of these technology changes do you think we implemented? None of them. We didn't do anything. Every time someone suggested a technology change, I put my fingers in my ears and shut my eyes and just rocked back and forth and moaned softly. The theory of constraints tells us to work only on the constraint. There is no technology change here that would have saved time for the release manager, slowed down the rate of work into the release manager, or created more time for them. Okay? So when people say we should do zero downtime deployments in WebSphere, I was like, not just yet, it doesn't matter yet. Or if someone said, perhaps we shouldn't have this manual crazy process at one point that's held together with sticky tape, I was like, no, that's fine. We only wanted to home in on things that could help this specific individual out of many teams in the process. Which of the organizational changes did we implement? We did a couple, and that was good enough. Firstly, we exploited the constraint. We created a shared call-out rota. We just went to all the delivery teams and said, fill out this rota for 6 months, and we might get to fortnightly releases. So that was done in a day. And the release manager was delighted because that removed a significant amount of toil. They were constantly writing chase emails to people, but we just took that all away in a day. Secondly, we built an automated release note tool, which the engineers were horrified by on the grounds it wasn't glamorous enough. And the 3 teams doing 4 release notes were horrified by because they were used to doing 4 different release notes. So I had to bribe the engineers into building it, and then I spent a lot of time understanding the needs of the various teams involved in release notes. And we managed to convince people to give it a try, run an experiment, see what it's like. And it was taken on and actually worked out really well, so that there was a huge reduction in errors in release notes. They happened much faster. And crucially, the release manager had early visibility of what was coming and didn't have to chase them anymore. And then finally, we elevated the constraint. We spent some money, wooden dollars at least, but we looked for more staff members to take on some activities off the release manager to free them up to concentrate on their day job around price management, which was much more important to the company. Here's our deployment throughput indicator after 6 months, and it's quite nice. The lead time stayed at 14 to 15 days, which was the goal. We were protecting that fortnightly lead time so that we could release every fortnight. And first of all, we successfully got down to 1 release every 14 days. We did that as an experiment. We said, hey, why don't we just try 1, maybe 2 in a row? And if that works, then maybe we just do it for good afterwards. We did 2 fortnightly production releases. Nobody died. It all worked really well. And then we permanently moved to fortnightly releases. And a year on, the company is still at fortnightly releases, which is fantastic. So here's a lead time breakdown that shows there was no constraint on the 14-day lead time. We continued to hit it with all of the existing processes, with all of the challenges and complicated aspects to the value stream that were just super challenging to tackle. And it also confirmed that the release test activity was still a constraint on weekly releases. But happily, the product owner found that fortnightly releases was enough to meet product demand, that they didn't want to spend another 3 to 6 months on going on to weekly releases. So we stopped at fortnightly. The intermediate milestone turned out to be sufficient to meet our needs. And that was great because it saved the company like 6 months of expensive engineering effort. And if we hadn't done fortnight releases as an intermediate step, like we would never have known that that would be good enough. Okay? So we're using the theory of constraints here to create options around target lead time, around product expectations. And then that means that we can actually reach a state of continuous delivery in a much shorter time frame, potentially. This worked out really well. And I was kind of surprised. I was like, wow, this is awesome. We can do this with all kinds of other stuff now. And then our whole team moved on to another thing in the company, which was awesome. All right, so what can I say? So I've got a couple of key learnings that I'd like to share with you. Dr. Goldratt was a very quotable man. Dan North once described him as this old Jewish guy who was great at telling stories, and that's definitely the case. So he once said that automation is good as long as you know where to put the machine. So that's definitely true, okay? Implementing continuous delivery is super hard. It's really easy to fail because there are potentially so many different things you could change, and it's really hard to understand what the few things are that you must change. And they might be really hard. They might be harder than creating a rotor and writing a release note tool and finding another person to share someone's work. In other companies, it will be different and it could be super challenging. But the crucial thing is to find those things as quickly as possible, right? Don't waste your time doing other stuff that doesn't make a difference to your lead time. The theory of constraints is the thing that can help you identify those problems really quickly. And you don't need to automate the world. You need to iteratively reduce your constraints until release candidates can be deployed as frequently as possible. You don't even have to eliminate your constraints. So if your constraint is like some awful, terrible end-to-end testing that I want nothing to do with, like, don't tell me about it, please. You don't have to get rid of it. You just have to speed it up to a point where you can release often enough. Okay? And if getting rid of it would cost you 6 months, but speeding up a little bit would take a month, then try that first. Just run an experiment. Once you've done that, you'll be in a state of continuous delivery, and that's awesome. Well done, you, like you've climbed the mountain. Okay, and here are some actionable takeaways. So I run a bunch of conferences, and I do a lot of reviews of proposals, and I always write, did not provide actionable takeaways. So it'd be hypocritical of me to like do a talk and then swan off and go, you figure it all out. So here are a couple of things that you can try for yourself that aren't terribly hard or won't take too long, okay? So establish your target lead time. This is easy. Just go to your product owner and say, hello, if you could wave a magic wand, how often would you like to deploy to customers? And then whatever their answer is, that is your target lead time to begin with. But that's not set in stone, right? Continuous delivery has a dynamic success criteria that can shift. It's not static like, say, continuous integration. Find the constrained activity. If you have lead time data, look for the thing that takes too long for your target lead time to happen. And if you don't have any data, look for the activity that has a bunch of work piled up in front of it and nothing happening after it, and maybe some people arguing about it. That's probably it. And finally, run some experiments that save constraint time. Just think of some stuff you can do that's in all the books, like trunk-based development, like test-driven development, whatever you can do to save time at that constraint, okay? And you'll be surprised at how quickly you start to see some success and get some good feedback going. Okay, thanks very much for having me. I did speak fast. I only went over by like a minute though, so no one's going to throw me out of France. So thanks for coming. Is there time for questions, or are we busting a groove? Okay. If anyone has questions, then I'll be stood here for a little bit, and then I'll be out in the corridor. Thank you again.